This video is on exercise 1A of the Further Maths core book textbook. So this chapter is on complex numbers, which is an introduction. And now I'm going to do some of these examples because all these examples follow the same pattern. So if you just see how and learn how that we can do one of these, then you can just apply that to the rest of them. So there isn't anything complicated with with these examples. They're all the same. So before I do this, just let me recall that I is equal to root minus 1. So the whole this whole branch of maths, which is just about complex numbers, and of course in A-level maths you just learn a tiny bit about that, but that simply that piece of maths is just that has been made by just only this fact, and many theories are there based on this fact. So now let's use this and write each of these in terms of I. So root minus 9, we can use our knowledge and rewrite this as 9 times minus 1. So root 9 times minus 1. And now we can use one of the rules which tells us that we can split sets, which means we can write this as root 9 times root minus 1. So root 9 is equal to 3, and root minus 1 is just I. So the answer is 3i, and that's it. So this is a very important skill to develop from now, because later on you will be using this a lot, especially when you solve equations. And yeah, now let's do the second one, which is exactly the same as the first one. So root 49 times minus 1, then we can split this and write this as root 49 times root minus 1, and then it's 7 times I, which is 7i. What about f? Because we know that root 5 doesn't have an exact answer. So let's start and just write root 5 times minus 1, which is root 5 times root minus 1. And here's the thing, it's fine if if we cannot simplify this, then just leave your answer in that form. So that simply means you have root 5i, but some people prefer to write this as I root 5, simply because not to think that this I is also under the root. So yeah, some people prefer to write as I root 5. Now let's do h. We have root 45 times minus 1, and this is root 45 times root minus 1. And we know that we can rewrite root 41 as root 9 times 5 times I, and root 9 times 5 can be written as 3 root 5. So the answer is I 3 root 5. And finally j, which is root minus 147. So again, the same process. So root 147 times minus 1 is root 147 times root minus 1, and root 147. So 147 can be written as 49 times 3. And this times I, which is I 7 root 3. Now let's do question 2. So in question 2, we have some additions and subtractions with complex numbers. And again, I'm just going to do these 3 parts because they're just very similar. So the rule simply states that whenever we want to add or subtract complex numbers, we simply have to add the real numbers and then add the imaginary parts to each other. So because we know that a complex number is in this form, a plus bi, And if you want to add this to something, let's say as c plus di, which is another complex number, then the final answer is going to be a plus c plus b plus di, which simply means that just add the imaginary bit and then add the real parts. So now we are going to use this, and so here we have 5, 8, which are our real parts. So 5 plus 8 is 13. 2i plus 9i is 11i, and that's it. So this is the final answer, as simple as that. So here a half and 5 over 2 are our real numbers, real parts. So a half plus 5 over 2 is 6 over 2, which is 3. And a third I plus 5 over 3i, which is 6 over 3i, which is 2i. So 3 plus 2i. And finally, the last one. So 3 root 2 minus root 2. So this is a subtraction, and we have thirds. So this and this are our real numbers, and this and this are imaginary numbers. So 3 root 2 minus root 2 and plus I plus I. So 3 root 2 minus root 2 is 2 root 2. I plus I is 2i. And that's it for this video. So thank you for watching. Make sure to subscribe to my channel so you won't miss the next videos, which are going to be on, just the exercises of A-level maths and further maths. Good luck.